Hello and welcome to Module 12, which deals with risk management in ship operations. Now, there are many different definitions as well as interpretations of the term risk. In terms of ship operations, I suppose no other term represents or sort of shows up the risks in ship operations other than the term marine adventure, which is often used in the insurance industries. Marine adventure means the voyage of a trading ship, and it's an adventure because a lot of bad things can happen to ships. So the issues facing the ship managers are basically threefold. First of all, identifying the hazards in ship operations. Secondly, assessing the level of risk in a particular operation. And last but not the least, deciding how to deal with that risk. So in this module, we'll look at the methods and techniques of risk assessment and risk management that can be used by ship managers. So the two focus questions are: what is risk in ship operations, and how is risk managed in ship operations? So the first question is, what is risk? There are, as I mentioned earlier, many interpretations of the term, but the most common ones are, or the most commonly held interpretations are, that risk is either a hazard, it's a chance of unwelcome outcome, or it's an uncertain decision. So for some people, risk means the same as hazard. A hazard in the safety context means danger to a person, damage to a property, or pollution of the environment. A second view of risk is that it is the chance of meeting with an unwelcome outcome. So for example, if someone invests their savings in shipping, that may be regarded as a risk. Why? Because one is in danger of losing all or significant proportion of the money that is invested. The third common interpretation is that of risk as an uncertain decision. So this term risk then is often used where it is necessary to come to a decision, but the outcome is quite uncertain. So if, for example, somebody says, I am taking this risk, what they are really saying is that they hope that they will get the desired result, but they won't be too surprised if it didn't happen. Let's look at a practical explanation of risk, and let's think about the question of injury to a pedestrian through a car accident while the pedestrian is crossing different types of roads. And let's consider three types of roads: crossing a street in a city center, crossing a street in an urban highway, or crossing an urban highway, or crossing an interstate freeway. So when we talk about the risk here, we are really talking about the seriousness of the accident as well as the consequence of the accident. Or rather, the seriousness is the consequence of the accident, and in this slide we denote it by the capital letter C, and the consequence is also, or should also, be considered together with the frequency or probability of an accident occurring, which is denoted by the letter P in this slide. So what if we were to plot the consequences of crossing the three different types of roads I mentioned earlier against the probability of an accident occurring, and we might come up with a graph which is shown on the slide. Let's take a scenario which is indicated by point 1 here. So point 1 explains, or rather shows, a scenario where we are talking about pedestrians crossing streets in the city center. Now, in a city center, many people will try to cross the street at random locations. Since the speed of traffic is generally low in the city center, pedestrian could normally avoid being knocked down by carefully timing their crossing between the movements of the cars and crossing over quickly. Or it may happen that sometimes an approaching driver would voluntarily slow down. However, the number of pedestrians attempting to cross street in the city center is usually quite high, and so it is possible that there would be a large number of accidents, even though the injuries that they might suffer may not be too serious. So in other words, The consequence of an accident in a city center street is low, but the probability of the occurrence is quite high. And as I mentioned, that is indicated as point P on this picture. If we take the second scenario, that's point 2, that's where we are talking about pedestrians crossing urban highways. Now, in urban highways, the traffic speed is fairly high, and most of the pedestrians will of course try to cross the highways at junctions which are controlled by traffic lights, or maybe through a overbridge or a footbridge. So as a result of that, because less people will be trying to cross the urban highway, the number of accidents will be lower than in the first scenario. But if an accident does occur, the consequence can be quite serious. So in scenario 2 then, the consequence is higher than 1, or rather higher than the scenario indicated by point 1, but the probability of the occurrence is lower. Let's take the case of an interstate freeway. That's scenario 3 indicated by point 3 on the slide. Now, in an interstate freeway where the traffic is hurtling down, at say 110 kilometers per hour or more, very few people will try to cross the freeway on foot, simply because the speed of the traffic is such that it will be very hard to find space between vehicles where it might be considered safe to cross. However, if an attempt is made to cross the freeway, and an accident does occur, it is likely to result in a very serious injury or even death. So in this case, the consequence is very high, but the probability of occurrence is quite low. So if you were to fit a curve over those 3 points, then the curve as shown on the slide will indicate that the probability of an accident occurring is almost inversely proportional to its consequence. So therefore, very few pedestrians will attempt to walk across a freeway, because any accident would be very serious or even fatal. On the other hand, a large number of pedestrians cross city center streets because potential accidents there are perceived to be less serious. So in mathematical terms, where consequence and proportion and probability are inversely related, mathematically we could show them as an equation: R equals C times probability, C times P, where R stands for risk. Now, there is no universally accepted definition of risk, but one that is commonly applied, and commonly applied in most industrial contexts, is the ISO definition on the slide, which is, if I read out to you, a combination of the probability or frequency of occurrence of a defined hazard and the magnitude of the consequences of the occurrence. The IMO defines risk as the combination of the frequency and the severity of the consequence. So essentially, they are talking about risk being a function of C and P, as we discussed in the previous slide. By the way, when these definitions talk about hazard, what do they mean by it? A hazard is a substance, or it could be a situation, or it could be a practice that has the potential to cause harm. So when we have risks, we need to manage those risks as well. So what do we mean by risk management? There is one definition, and that definition says risk management means managing and controlling the risks of hazards to ensure that they are always at a tolerable or negligible level. So what do we mean by tolerable and negligible levels? Well, according to one of your readings, the UK Health and Safety Executive, they divide risks into 3 categories, and those are negligible, where no risk reduction measures are needed. The second category is tolerable, where the risk should be really as low as reasonably practical. As low as reasonably practical could be stated as ALARP, A-L-A-R-P. I'll talk about that in a later slide. The third category of risk would be that the risks are intolerable. What that means is, if the risk is considered to be intolerable, then risk reduction measures must be taken regardless of the cost. So The actual assessment as to what is as low as reasonably practicable or practical is linked to a, say, sort of a cost-benefit analysis, and we'll look at some examples later on in this presentation. In terms of the process, this diagram illustrates the risk management process, and I would like you to just go through what these what the process represents, and you might find similarities with the total quality management principle that we discussed in the previous module. However, in this presentation I mainly want to stick to the first point, or the critical step that is identified on the slide, which is the identification of hazards. And that is the first and perhaps the most important step, because all that follows depend on hazard identification. So hazard identification must be accurate, and wherever possible should be based on observation of the activity. But it's not as easy as it may appear. You know, I'm talking about hazard identification. It's not as easy. Not always the hazards are easily identified, and often people charged with the task of risk management have specialist training, and just to ensure that the risk assessment and the whole risk management process is conducted in a systematic, thorough and consistent manner. Now, the risks which are associated with each of the hazards that are identified, they need to be then evaluated in terms of the likelihood of harm and the potential consequences. Once an organization like a shipping company does that, then it can establish priorities and can decide where resources may be used to the greatest effect. Normally, the combination of likelihood, which is the probability, and consequence is illustrated in the form of a table like shown on the slide here. Having said that, the table which is shown here is in a form in which is in the most commonly expressed form, but you know, it's not mandatory to use this table, and of course this matrix, this risk matrix, may be expanded to include more rows and columns depending upon how finely the shipping company may wish to distinguish the various categories of risk. Because essentially what this risk matrix is doing is it's identifying the category to which a particular risk may belong to based on its consequence and probability or likelihood. So the category could be that your risk is just a trivial risk, let's not worry about it too much, or it could be substantial risk, in which case we would have to do something, we can't ignore it. Okay. And coming back to the practical application of this risk matrix, the terms used for the likelihood and consequence, then they could be changed so that changed in a way so that the managers who are doing the risk assessment, they get a better understanding. Now, for example, in terms of the likelihood or probability, you might express it in terms of once per trip of a ship or once per ship year. The consequence may be made more specific by the use of, say, if we are talking about injury, it could be first aid injury, serious injury requiring prolonged hospitalization, or even death. In some cases, and in many cases, a dollar value may also be attached to the consequences. So when deciding on or rather, once you have determined the level of risk, whether it is trivial, tolerable, moderate, substantial or intolerable, the next thing is to decide what to do about it. And often you would find that the companies who do risk assessment, they would also have table or something similar which indicates the recommended response in each case, and an example is given on the slide here. So if a risk has been identified as trivial, the recommended response would be don't do anything. If on the other hand it has been identified as moderate, well, then efforts would be needed to reduce risk. Similarly, if the risk has been identified, a particular risk has been identified as intolerable, work would not start or should not be allowed to start or continued until the risk has been reduced, or if the risk is if it's not possible to reduce the risk, then you have to simply cancel that activity. When deciding on what controls to be applied or the priorities for the actions, it would be a good idea to consider the frequency of the activity, because, for example, there might be a moderate level of risk in a process that occurs every day, but that may require much more urgent attention than to try to take action to reduce risk for an activity that involves substantial risk but will not be carried out in the near future. It should also be mentioned that the terms that are applied to the levels of risks in the table that are shown previously, they shouldn't be interpreted too rigidly. Risk should be reduced to a level that is as low as is reasonably practicable. If a tolerable level of risk can be reduced still further for a reasonable cost and with little effort, then it should be, because standards of whether a risk is tolerable or not, they tend to be far higher or stricter after an accident than before it. So this as low as reasonably practicable or ALARP concept, that is illustrated in the next slide, this one. Well, what does the ALARP triangle indicate, and what is really the ALARP principle? Well, in determining how much risk reduction should be done and whether possible solutions are cost effective or not, that's where the ALARP principle can be utilized. The term is derived from a legal interpretation of a court judgment, and the key words from the judgment are given in one of your readings. I'll just read it out to you here as well. And what it says is, the methods of reducing the risk level of a hazard can be put in one scale and balanced against the effort needed to reduce the risk in another scale. The effort may be represented by money, time, or a combination of the two. If it can be shown that there is a gross imbalance between the two, for example, the reduction in risk level is insignificant compared with the cost of implementing the proposed solution, it would not be reasonably practicable to go ahead. So the rationale behind the ALARP triangle as illustrated here, that can be summarized in two ways. First of all, the inverted triangle means that a high risk hazard should be pushed down towards the negligible risk region, and secondly, the tolerable region should be the ALARP region. That is, all the hazards in the tolerable region have to be examined or should be examined to see if they can have their risk level reduced further. According to your reading that mentions the ALARP triangle, it has been a UK legal requirement for the ALARP principle to be applied when the safety of a system or equipment that involves a large number of users is being considered. Now, the popular approach in risk reduction is to, as I mentioned in the previous slide, is to adopt a three-region risk presentation, and we can give names to those regions, which are intolerable, tolerable, and negligible. So risk reduction then becomes a term which is used to describe the movement of a hazard from one location which is higher on the risk scale to a lower location. So as a result of risk assessment, hazards can be distributed throughout these three regions. So it is of course essential that we reduce those risks in the intolerable region to the tolerable region. But it may not be cost effective to move any of the risk from the tolerable to the negligible region. So bearing in mind that there are bound to be hazards in any system or work, it would be useful if certain fundamental guidelines could be established for risk reduction. And those guidelines are shown in the slide in front of you. First of all, if the hazards are in the intolerable region, then one should eliminate the hazards or eliminate the hazards which are in the intolerable risk levels. If it is impossible to achieve the risk reduction cost effectively, then you need to give serious consideration to either you abandon that activity or project or whatever it is, you abandon it for something else which does not have such a high risk level. If a risk is in the tolerable region, then one must consider whether it is worthwhile to reduce those risks, those hazards, I beg your pardon, by asking two basic questions. First of all, we need to ask ourselves, is the hazard close to the intolerable region? If the answer is yes, then even if it is expensive, it may be better to reduce the risk. The second question to ask is, can the risk reduction be done cost effectively? If the answer is yes, then it would be sensible to reduce that particular hazard, regardless of where it is located in the tolerable region. As far as hazards in the negligible region are concerned, I suppose these could be left alone. It would, of course, it may not be cost effective to try to reduce the risk level further, but from time to time risk assessment should take place to examine these risks, just to make sure that these risks have not moved up the scale. So we've been talking about reducing the risk. What are the different options for reducing the risks? Fundamentally, there are three basic options. One is to reduce the severity of the consequence. Second is to reduce the probability of the occurrence. Or we reduce both the consequence as well as the probability. How do we do that? We can apply management methods, engineering methods, operational methods, or a combination of these methods. So what are these methods? Well, management method, as you can make out from the name, that involves activities that are related to the management of the company. So from a ship operations perspective, the most important solution there would be in management method would be the development of a safety culture. That would mean changing the people's attitude to safety, their behavior in a safety context, and basically making it business as usual practice to carry out tasks in a safe manner. Another illustration of management method would be to put resources like money into the training of staff, especially in safety matters. When we talk about engineering method, essentially that involves in the context of a ship, it may involve things such as changing or having a safe design of the ship, or constructing the ship in a particular way, installing additional safety equipment, for example. One example could be, if you think back to our lecture on where we were talking about tankers, I mentioned double hull tankers were introduced, and that was actually done in order to prevent oil pollution from occurring in case the ship ran aground. So that's an example of reducing the risk through an engineering method. As far as the operational method is concerned, typical solutions used in this type of method would be devising new or appropriate procedures for doing tasks which are safety critical tasks. Also improving the competence of the people who do those tasks by regular practice, for example. These solutions, operational method solutions, are quite useful because often the people who design equipment, they do not, or they may not necessarily appreciate precisely how a given equipment will be used in practice, and hence its safety implication. An example of an operational solution would be a procedure on board a ship which requires very careful route planning, and that would be done so that the ship can avoid grounding. In practice, it is usually necessary to employ a combination of all the three. So if we take a typical example, risk reduction could be achieved by introducing a new or modified piece of equipment into the ship. Then it would be supplemented by providing a new operational procedure for its use. And thirdly, resources would be set aside or used to train crew members so that they can reach the necessary level of competence in using their equipment safely. Now let's look at some issues concerning what we have been speaking so far. If we think about the Allard principle again, now since the reduction of risk involves both the effort needed and the risk level achieved, the term, therefore, Allard term that is, implies that you need to have a balance between the amount of effort needed to reduce the risk and the level of risk reduction achieved. In terms of effort, that can be measured by means of the cost involved or the time spent or a combination of the both. But the word reasonably in the Allard acronym, that indicates that the effort that is needed to achieve a given reduction of risk should be appropriate, and really it's the term practicable that holds the key. What that means is that regardless of cost, time or effort, if a risk reduction method is not practical, it's unsuitable. Now some people would argue that the Allard principle is too vague and could be interpreted in many ways. Well, they are right in the sense that yes, there are different types of ships and systems are operated by different methods. The Allard principle is just a principle, and that should be adapted to, or then that can be adapted to individual situations. It's also possible to consider the Allard principle in another way by considering the so-called Pareto principle. Now some of you may be aware of this. This principle is due to a person named Pareto, who was an 18th century Italian economist. He noted that at that time 80% of Italy's worth was in the hands of 20% of the people. And when this principle or this observation was applied to other instances and other situations, the same trend seemed to appear. So in general terms, we can state the Pareto principle as being that 20% of the effort applied will achieve 80% of the goal, while the remaining 80% of effort will be needed to meet the remaining 20% of the goal. Cost benefit analysis or CBA methods have been applied in many subjects area to assist in decision making, and here the basic concept is to put costs and benefits on a common basis. Usually that common basis would be in money terms or monetary terms, and if you put the costs as well as the benefit in the same term, then a comparison can be made between the various possible options much more easily. So in the context of safety, if we are using the cost benefit analysis, we would need to relate the costs of various risk reduction options achieving some desired benefits, and thereby enabling some comparison to be made in a consistent manner. So the purpose is to determine whether the risks levels can be further reduced cost effectively. Having said that, the practical application of the cost benefit analysis method is far less straightforward, and there are a number of reasons for this. First of all, in the case of safety, now safety, or the concept of safety, idea of safety, is dependent to a large extent on personal perception, and therefore, in order to determine the benefit, one may need to make a lot of assumptions. So if you're making assumptions, if they are not correct, then they can give misleading results. Secondly, there is no direct correlation between costs and benefits, because for example, the costs relating to safety matters are not constant over time. Usually, if you are putting in something new in a safety context, there would be a very high initial cost. That would be followed by lower yearly maintenance or recurring costs. The third thing is that the costs and benefits, they generally arise in different time periods. Usually you would need to spend money upfront or early so that you can implement a risk reduction measure, whereas the benefits can then occur every year. And last but not the least, the results of a cost-benefit analysis can depend on the person carrying out the study and the organization they represent. For example, a government department doing a cost-benefit analysis might use a slightly different methodology than a shipping company. Now, once it's been established that company is exposed to risks, then managers have a number of choices. So far we have only talked about the reduction of risk, but of course in some cases risks could be retained, but risks could be transferred as well, and risk transfer happens very often. Risk transfer can be achieved in a number of ways. For example, on a ship, let's say between two parties, the terms under which they trade, they are negotiable. And say if you take the case of a charter party, it may be possible to reduce the ship owner's exposure to the costs and market conditions by putting in appropriately worded terms, provided of course the charterer agrees. Another way that the risk transfer could be achieved would be that the shipping company may put the ship out to a ship management company and a third party, so that the risks of operating the ship is borne by the ship management company. Another way that the risk transfer could be achieved would be, for example, to have the ship be operated by crew which are employed using a crew management company. So there's a number of ways that risks can be transferred, but obviously the most obvious way, I suppose the most common way of transferring risk is through insurance. So what happens in the case of insurance is that the shipping company transfers the risk to the insurance company, which takes over the risk, but of course for doing that it charges a premium as well. So from a ship owner's point of view, they would need to negotiate premiums in the choice of insurance companies such as P&I clubs, and they would need to weigh them against the service provided by those companies, in order to determine what risk they want transferred. In terms of ship insurance, the two most important or significant insurance for the ship owner are the hull and machinery and protection and indemnity. Hull and machinery, or rather the protection and indemnity insurance is something like a third party cover that you take out for a car, whereas hull and machinery might involve say a fully comprehensive car insurance, similar to that. Similar but not really. There are differences. I suppose the car analogy is not entirely correct. Hull and machinery insurance covers the ship itself and the equipment on board the ship, and that includes the engines, the propulsion machinery, that is the auxiliary machinery, cargo handling and navigational equipment, and similar type of equipment. Protection and indemnity cover is needed. Why? Well, during the course of operating ships, a ship owner can incur liabilities towards other third parties. So the protection and indemnity of P&I insurance, that provides third-party liability cover. And P&I cover may also be provided for other losses which a shipping company may suffer, for which they may not be those losses may not be insured elsewhere. Additional insurances could include insurances for freight, demurrage and defense. So examples would include the disputes under charter parties and disputes arising from sale and purchase of ships. So in those cases where there are disputes, freight, demurrage and defense cover will provide insurance not for those risks themselves but for the legal costs. So it covers the cost of providing legal and technical support and assistance. Strike insurance, as you can make out from the name, is available to deal with any losses which may arise from strikes. As far as war risks are concerned, if a ship finds itself in a war zone or other areas where there are hostilities, the normal hull and machinery and P&I insurance may be suspended. So war risk insurance provides the shipping company with continuity of cover as may be required. So just to, I suppose, summarize, before I summarize, I should mention here, I'll be talking about the cover that is provided to the ship owner, but there is another party involved as well which actually owns the cargo, and the cargo may be owned by the charterer, but in majority of cases it belongs to a third party. Now whoever owns the cargo would usually arrange for insurance cover on the cargo to protect themselves against loss or damage, as well as their own contribution to general average and salvage. What do we mean by general average? General average is just a maritime law concept whereby if some intentional sacrifice is made on board a ship, then the parties that benefit from that sacrifice may have to contribute to make up for the loss suffered by the party whose cargo or may have been sacrificed. So say for example, if a ship runs aground and in order to refloat the ship, some of the cargo is thrown over the side, then ship refloats, continues on its journey. So under the principle of general average, somebody has suffered a loss and that person is the one whose cargo was thrown overboard, but the other parties like the shipping company and the other cargo owners have benefited. So those cargo owners would then contribute to make good the loss suffered by the party whose cargo was thrown overboard, and that principle is known as general average. It is important, however, to realize that what cargo underwriters cover is different to what P&I clubs cover. P&I clubs underwrite liability. That's why shipping companies need them. This was the last module in this unit, and it's now time to basically revise the concepts learned in all modules so that you can prepare for final exams. Now, as a starting point, you should review the learning outcomes of this unit, which are in the unit outline. A good way of revising what you have learned or what you have been certainly been exposed to in this unit would be to read the focus questions in all modules and see if you can answer those questions. If you can answer those focus questions satisfactorily, then you should be well prepared for the exams. Have a look at the key terms and concept checklist in all the modules to refresh your memory, and if, as I suggested in the very first module, you did start up your own glossary of shipping terms and the list of conventions and codes, you may want to go over them just to see if you can still or you know what those terms mean and just the basics of what's covered in those conventions and codes. Good luck with your exams, and bye for now.